Hello everyone, and welcome to the second 11 Plus Maths walkthrough. This time it's the 2008 Haberdashers paper, and it's a good one. Okay, there are some really hard questions in this, and you don't get explanations of these sorts of questions online. So a little bit of admin. There are 61 marks in total, and the way you should mark this as we go through it, 1 mark per part of every question, unless I say otherwise. Okay, just like last time, I'm going to go through the entire list of answers, and then I will focus in more detail on those of the questions that are more difficult or unique. Okay, I'm not going to spend time telling you how to do 39 plus 45, and that's not the aim here. Okay, so we have 39 plus 45 is 84, then 73, then 504, then 18. Down here we have £6.49. Remember, you do need the symbol for pounds, or you need to write pounds. Okay, without the unit you do not get the mark. And here we have £79. This is obviously 14028. The largest of these fractions is 9/16. In order of size, these numbers are 0.005, 0.024, 1.006, and 1.01. If you for some reason converted these into fractions or something like that, if you converted them to a different form in order to compare them, you shouldn't have written the answer in that form, right? You should have converted back into decimals for the answer. Here we have 48. Okay. The blanks here should be filled in as follows. This is a 5 and this is a 4. This is a 6 and this is a 4. In this recipe we should have 5 onions, 500 grams of potatoes, 1000 grams of chickpeas, and 2.5 or 2.5, however you write it, teaspoons of curry powder. Okay. Now we have 36 hours here. You need to write hours. Actually, no you don't. How many hours did it take? If you write 36, because they're asking you how many hours, you don't actually need to put hours in this case. So if you put 36, that's enough. Okay, this is 9 hours a day. Again, you don't need to write hours a day. But just to be safe, in both of these cases, I would actually write it out. So now 9 hours a day. This is £90. This is £36. This is 23, and this is 9. Question 15. We have true, false, and false. The original record here is 82 meters, and the second answer is 64 meters. Now the next question is the first of those that are marked a bit differently. First, let me tell you the answers. It should be 6 here, 4 here, and 10 here, 8 here, 12 here, and 20 here, 14 here, 16 here, and 30 here. And in total you get 3 marks. Now, how do you lose marks in this question? If you make one mistake, so if any of the numbers are wrong, you lose a mark. And if you make another mistake, if a second one of the numbers is wrong, you lose another mark. And then if you make 3 mistakes, even if the other 6 numbers are correct, you get 0 marks. So basically you take away 1 mark for every wrong number that you write. Okay, so deduct 1 mark for each error in the table. So yeah, please don't expect questions like this, guys, to be 9 marks. This is not a 9-mark question. It's a 3-mark or 4-mark question, and this is how you lose the marks, okay? It's not hard enough to be a 9-mark question. Right, let's move on. This is 220 kilograms. This is 57 kilograms. This is 52 is the answer here. 52 years old. Then we have 21 seconds. And to fill in this table, we do it like this: 3, 15, 21, 12, 6, 24, 1, 7, 11, and 19, and finally 2, 22, 4, and 16. Okay. Right. How many millisocks are there in 3/4 of a ton socks? It's 15,000. Oh yes, and for this table, it's a 4-marker, and it's the same as before. Okay, you deduct 1 mark for every error. Now, question 23. The answer is 31 plus 5 squared equals 56, and 56 plus 6 squared equals 92. Right, another table, okay, and what you should do is give yourself 1 mark for each fully correct row, 4 marks in total, and it should be filled in as follows. 1, 1, 2, 2, 0, 1, 0, 2, 1, 2, 0, 2, and 0, 0, 1, 2. This is a really, really interesting question. It's about ternary numbers. If you've heard of binary numbers, the 1s and 0s that computers use, this is like that, but they are ternary, so you can use a 0, 1, or a 2. So we'll talk a little bit more about that when we go through it in detail. And the next question has the answer 200. Okay. Now, here we have 27 small cubes, then we have a 2 here, 19 and 26. And question 27 is marked as follows: 992, 299, and 12. And I think this is the last page. We have 14 pence, but I'm going to write it as 0.14 pounds. Both would be fine. £2.10 for this one. 26 marbles. 2 minutes. Then we have 20, 35, 60's filled in already. We have 80 here and 120. And of course you get 4 marks for this, right? So consider these 4 separate questions. And at last, we have 5 hours and 15 minutes here. Okay, so that's the simple mark scheme. Add up your marks, divide it by 61, and find the percentage. And now, in the next part of the video, we will go through those of the questions that are, really not found in your standard 11+ papers. Okay. Right, so it turns out there's quite a lot of questions I think we should go through in this paper. So let's start with 11. Let me delete the answers. So fill in the blanks in these sums. So this is pretty easy, but maybe I'll show you a systematic way of approaching this question. Okay, so the best way to do this is simply to think through how you would add these two numbers if you were doing long addition. Okay, so you would start by doing 4 plus 8, which is 12. So you would write the 2 here and you would carry a 1, right? And so you have to realize that to get this 2, this number 2 here, whatever this number is here, that number was added to the 6 and to the 1. So to 7, right? So 7 plus something gives you a number that ends in a 2. Obviously the number isn't 2, okay? It's probably 12, right? It can't be 22 because to add something to 7 and get 22, that something would have to be more than 10. And this is only one digit, so there's no space for a number more than 10. So it must be that we're getting 12, and 7 plus 5 equals 12. Right, so this number is 5. And once again, because we get 12, we write a 2 and we carry a 1. And so we now have 1 plus 1 plus 2 is 4. So the answer is 422. All right, so let's look at this one. This is a subtraction, okay? So you start with a 5, you take something away, and you get 9. Okay, so clearly that something is 6. Right, that's how this works. Right, you kind of go below 0, so to speak, by 1, and you get a 9. And then you continue to the left, right? And you're thinking that, well, you kind of, you're going down 1, whatever you get. So you do 0, take away 5, and that gives you 5. And you see you've already gone sort of below 0. And when you add the minus 1, when you take away the 1, you go from 5 to 4. So this answer here must be 4. And we once again carry a minus 1. And now we have 3, take away 1 is 2, and take away another 1 gives us 1. And that's exactly what we should get, right? So this works out. Just think through doing the calculation yourself, and you will get the numbers. This is an easy enough question, so I won't go through it, but this I do want to focus on, okay? So a man builds a garage in 6 days, working 6 hours a day. How many hours did it take altogether? Well, this is pretty easy, right? If you work 6 hours a day for 6 days, that's 6 times 6 is 36. Okay? So 36 hours. Now, if you wanted to finish the job in 4 days, for how many hours a day would he have needed to work? The idea here is that to build this house, this garage, clearly it takes 36 hours of work, right? It doesn't matter whether you do them over 6 days or over 100 days or over 4 days. It takes 36 hours of work because this man worked for 36 hours and only then did the garage get built. Okay, so our job now is to compress these 36 hours into 4 days of work. Okay, so the idea is that we have to assume, of course, that he works the same number of hours for each of these 4 days. So what we do is we do 36 divided by 4, which gives us 9. So he must have worked for 9 hours for each of those 4 days, and then over those 4 days we get 9 times 4 equals 36 hours of work, which is the same amount it took in the first case, so 9 is the correct answer, 9 hours a day. Right, yes, so in this question, it's not the hardest question, but there's this part of D which I want to talk about briefly. So let's go through the whole question. How much would 18 seats in the stalls cost? Well, this is very easy. You just do 18 times 5, right? Because 5 is the cost of a seat in the stalls, and you get 90. So £90. How much more expensive would it be to take 18 seats in the circle? Right, so this is a comparison question, right? How much more expensive would it be to take 18 seats in a circle? So let's calculate what it would take to take 18 seats in a circle, right? It's 18 times 7, I won't write it as the answer, I'll put it up here. 18 times 7, right, this is 70 plus 56, which is going to be 126, and we compare this to 90, so we do 126, take away 90, this is 36. So it's clearly £36 more expensive to buy 18 seats in the circle. There is another way to do this. You could say, well, each of the seats in the circle costs £2 more than a seat in the stalls, right? 7 is 2 more than 5. So if you buy 18 seats in the circle rather than 18 seats in the stalls, you're going to get 18 times £2 difference. And you can see that 18 times 2 is 36, so you get the same answer. But there are those two ways. C. How many seats would be bought in the upper circle for £92? Well, what you do here is you divide 92 by 4, right? Division, dividing one number by the other, answers the question, how many times does the second number fit into the first number? And that's exactly what we want to know. We want to know how many times does £4, the cost of one seat in the upper circle, how many times does that fit into £92, which is our budget for these seats. So 92 divided by 4, right, you can do it using long division. 4 goes into 9 twice. The number 4 times 2 is 8, right? The remainder is 1. 4 doesn't go into 1, but it does go into 12, and it goes into 12 3 times. So it's 23. Right. Good. So we can buy 23 seats in the upper circle for £92. And finally, this is the interesting bit, part D. If you had to buy at least one of each type, what is the maximum number of seats that could be bought for £41? Right. So what's going on here? Now, if we didn't have to buy at least one of each type, and we simply wanted the maximum number of seats for a certain amount of money, we would simply buy as many of the cheapest seats as possible, right? The cheapest seats are in the upper circle. We just cram as many, £4 tickets into these £41 as we could. But we need to have at least one ticket in the stalls and at least one ticket also in the circle. So what we're going to do is get one ticket in the stalls for £5, one ticket in the circle for £7, and then the rest of them we will get in the upper circle, right? 5 plus 7 is 12, and 41 take away 12 is 29, which means we have £29 left to buy as many £4 upper circle tickets as we can, right? And 28 is the closest multiple of 4 to 29, right? 28 is 4 times 7, which means we can get 7 tickets in the upper circle, right, for these remaining £29. So we get one ticket in the stalls, right? I'm underlining this because that's the cost of it. The second ticket in the circle, and the remaining 7 we get in the upper circle, and then 1 plus 1 plus 7 is 9. I hope it's not too confusing, because this is the cost of the ticket and this is the number of tickets, but I think you get what I'm trying to say here. Question 15. Answer true or false for each of the following statements. When you multiply an even number by an odd number, you get an even number. That's true, right? If you multiply an even number by any other type of number, as long as it's a whole number, you get an even number. Why is that? Because an even number has a factor of 2, right? It's divisible by 2. And when you multiply two numbers together, the product of those two numbers inherits the factors of each of the two numbers. So, for example, if I do 4 times 9, 4 breaks up into 2 times 2, and 9 is just, let's just keep it as 9. So the answer to this can be written as 2 times 2 times 9, which is 2 times 18. And you can see that you can't avoid having this factor of 2 in the answer if one of the two numbers has it, right? So the answer is necessarily even. 36 in this case. Right, part B, when you add an even number to an odd number, you get an even number. Well, obviously not, okay? Right? If we do 4 plus 3, we get 7, which is not even. Okay. When you multiply any two numbers, the answer is always bigger than either of them. Okay. Well, if we're talking about whole numbers, more than 1, then this is true. Right? If you do 2 times 3, the answer is 6, and 6 is bigger than 2 and bigger than 3. But if you allow 1, already we have a problem, right? Because 1 times 3 is 3, which is bigger than 1, but it's not bigger than 3. It's equal to 3. So it doesn't work. And then if you allow numbers less than 1, this obviously breaks down, right? 0.5 times 0.5 is actually less than both of them. This is 0.25, right? A half times a half equals a quarter. So this statement C is just completely wrong. Okay, let's go through this 18. The average weight of 4 boys is 55 kilos. What's the total weight of the 4 boys? Clearly 55 times 4, which is 220. A 5th boy whose weight is 65 kilos joins the group. What is the average weight of the 5 boys? So average means the mean average. Okay, so I know there are different averages, mean, median, mode, but when it just says average, that means the mean average. Okay, so what do we need for the mean? We need the total, and we need the number of boys. So we need the total weight and the number of boys. So the total weight will be 220, which is the weight of the 4 boys that were there in the beginning, plus 65, the weight of the 5th boy, and that will need to be divided by the number of boys, which is now 5. Okay, 220 plus 65 is 285, and dividing 285 by 5 is simple enough. You can do it by long division if you like. Okay, but let me take this opportunity to teach you a trick of mental maths. To divide a number by 5, divide it by 10, and then times it by 2. So 285 divided by 10 is 28.5, and it's very easy to do 28.5 times 2, right? This is 57. The reason this works is because 5 times 2 equals 10. So if you multiply a number by 10, that's 2 times bigger than multiplying it by 5, right? So if you multiply it by 10 and then divide by 2, that has the same effect as multiplying by 5. And in our case, when we're dividing by 5, right, dividing by 10 would be dividing by 2 times as much as dividing by 5. So what you do to divide by 5 is first divide by 10 and then times by 2 to adjust it, right? And the overall effect will be the same as dividing by 5. Now, why do we even do this? Simply because dividing by 10 is very easy. You just move the decimal point. Similarly, multiplying by 10 is easy. You just move the decimal point the other way. And also multiplying by 2 and dividing by 2 is very easy. So if you have to do things in your head, so if you have to do mental maths, it's often much easier to do it this way than to actually think about dividing by 5 directly. I hope that helps. Question 19. The ages of Henry, James and Toby add up to 104. Henry's twice as old as James, and James and Toby are twins. How old is Henry? So this is a classic question where it's helpful to write H, J and T and write some algebraic equations connecting them. Okay, so H will be the age of Henry, J the age of James, and T the age of Toby, obviously. So we can write first of all that H plus J plus T is 104. And what you do essentially is go through the sentences of the question and convert each of them into an equation, right? So we've done that to the first sentence. Now the second. Henry's twice as old as James, and James. Okay, let's stop here. Henry's twice as old as James. We can write that as H, the age of Henry, equals 2 times J, the age of James, right? If you do times the age of James by 2, you're going to get the age of Henry. And finally, James and Toby are twins. If they're twins, they have the same age, right? So it must mean that J actually equals T. Right, so the question is, how old is Henry? The way you do these questions is you try to get one equation that has only one letter, only one unknown in it, right? What you're actually solving here, if you've heard of that already, are simultaneous equations, right? Equations that are solved at the same time. And you can see that if we only had one equation out of these three, or even just two, we wouldn't be able to solve for the numbers, right? For example, if we just knew that J equals T, well, great, but we don't know what J and T actually are. And even if we had these two, where we know that J equals T and H equals 2J, well, we can do something like change this J here and replace it with T, right? Because J is the same as T, so if H equals 2J, it must also be true that H equals 2T. But because we have this third unknown H here, two equations won't be enough, right? In general, you need as many equations as there are unknowns. We have three equations here and three unknowns, so this can be solved. And the way you do it is you look at usually this equation here, and you just replace, you use the other two short equations to replace the letters in the big equation by the same letter. So H, I'm going to change that for 2J, and this J I'm going to keep the same, plus J, and this T I'm going to change that to J because T and J are equal. So you see, I've rewritten this first equation using only J. And now I can actually find what J is, because 2J plus J plus J is 4J. 4J equals 104. 104. 104 divided by 4 is 26. So J is 26. Because J equals T, T also equals 26. And finally, because H equals 2J, H must equal 52, which is 26 times 2. Right, so the question was, how old is Henry? And indeed, we know now Henry's 52 years old. Fine. Okay. I will quickly go through also question 22. On planet SOX, there are 10 millisoxes in a gram SOX, 20 gram SOXes in a kilo SOX, and 100 kilo SOXes in a ton SOX. Clearly, they're just messing around here, and they've changed milligrams, grams, kilograms, and tons into whatever this is, right? They've added milli-SOX. You know, they've added SOX at the end of all the usual words. So we treat them very much the same as grams and milligrams and kilograms. So the question is, how many milli-SOXes are there in 3/4 of a ton SOX? And as you probably know by now, if you want 3/4 of something, it's easiest first to find that something and then find 3/4 of it, right? So we will find what a ton SOX is in terms of milli-SOXes and then just times that by 3/4. So let's build up to it. If there are 100 milli-SOXes in a gram SOX and there are 20 gram SOXes in a kilo SOX, then there are 10 times 20 equals 200 milli-SOXes in a kilo SOX. Make sense? And now, if we know that there are 200 milli-SOXes in a kilo SOX and that there are 100 kilo SOXes in a ton SOX, we can do 200 times 100 equals 20,000. And there are 20,000 what? Milli-SOXes in a ton SOX. Okay, the question is how many millisocks are there in 3/4 of a ton socks? We just need to find 3/4 of 20,000, and you know the easiest way to think of that is what's 3/4 of 20? Obviously that's 15, so the answer will be 15,000, which is what it is. I hope that helps, and you know maybe briefly I'll say that in question 23 you have a sequence where you're adding square numbers to the previous numbers. You start with 1, then you add 1 squared, you get 2, and then to that you add 2 squared, to that you add 3 squared, and so on. So this question can kind of look difficult, but if you just look at the pattern, you realize it's not difficult at all. Sorry, this should go like that. Okay, you just add the next square number. It's pretty simple. So all I want to say here is don't be scared off by notation, you know, by how things are written. So don't look at a question and go, oh no, it's got squares in it, it must be hard. No, it's probably very easy. Well, not probably, but it could just be very easy. Now, when it comes to this question 24, there is more to it than simply trial and error and finding the right number of 27s, 9s, 3s and 1s to make each of these numbers on the left here. If you notice, these numbers 1, 3, 9 and 27, these are powers of 3. 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, and 3 cubed, 3 to the power of 3 is 27. So you're trying to make these numbers on the left by combining multiples of powers of 3. So you can have up to 2 of each of them, but you can't have 3 of one of them, because if you have 3 9s, for example, that's the same as 127, so you simply add 1 to the 27 column instead of saying that there are 3 9s. Similarly, if you've got 3 3s, that's 1 9, so you simply put 1 in the 9s column rather than saying that there are 3 3s. And that should remind you of the way we write numbers in general, but usually we do it with powers of 10. I'll do an example down here. Think about the number 287. This 7 here is 7 times 10 to the power of 0. Anything to the power of 0 is 1, so 10 to the power of 0 is 1. 7 times 1 is 7. This 8 here, this is 8 times 10, right? Because it's 80. This 8 represents 80. So it's 8 times 10 to the power of 1. This 2 is 200. That's 2 times 100, which is 2 times 10 squared, 10 to the power of 2. So we usually write numbers in terms of powers of 10. And, for example, when we have 10 in the units column, so let's say we go past 9, right? 9 is the greatest digit we can use. But if we go past 9 and we want to write 10 in the units column, we don't write that. We write a 1 in the tens column because that 1 represents 10 units. Just like in the table here, as I explained before, we, for example, when we have 3 1s, 3 times 3 to the 0, we don't write a 3 in this column. The maximum digit we ever write is 2. We write a 1 instead in the 3's column. And this way we can write bigger and bigger numbers, and we can represent any number we want using this system. Now, you have probably heard that the system we usually use to write numbers is called the decimal system. Decimal means based on the powers of 10. Right? That's the usual system, and that's the system that these numbers are written in. The system in which we've written numbers here, for example, the bottom number here, 2222, this is actually the number 80. Written in, this is 80, or I should write it as a word, right? So 80, written in the ternary system. Okay, so decimal system for powers of 10, ternary system for powers of 3. You have probably heard of binary. Binary is the ones and zeros that you might see computers dealing with, right? And here, these are based on powers of 2. And because they're based on powers of 2, the maximum digit that we can use is 1. So we can only use zeros and ones. When we move up to ternary, we may use zeros, ones, and twos. And when we move up all the way to decimal, we may use zeros, ones, twos, threes, fours, fives, sixes, sevens, eights, and nines. I hope that makes sense. And you can even go beyond decimal and have things like the duodecimal system that's based on the powers of 12. But maybe we can talk about that another time.